General form of square root function is y is equal with a square root of bx minus h plus k. A indicates a vertical stretch or vertical compression of the square root function. B indicates horizontal stretch or horizontal compression of the square root function. X is the argument of the radical function. H indicates the horizontal shift or translation of the radical function, and K indicates the vertical translation of the radical function, respectively of the square root function. But now here we have one example, and we don't want to talk about the other issues. What we want to talk here, is just about the vertical translation. We have three functions here. The parent function f of x is square root of x. Let me call this a blue function because it has a blue color. And a red function because of the red color. F of x is a square root of x plus 2. And green function, f of x is a square root of x minus 3. So the parent function we already graphed in the other video, which is the graph here, the blue function. And if we have f of x is equal to x plus 2 is similar with the parent function, but the only difference is here is a plus 2, so the k is a plus 2. What's happening with this function is going to shift the graph of the function for 2 units up, because here is plus 2, so the graph of the function is going to translate vertically for 2 units up, and all the points in the graph are going to translate vertically for 2 units. Now the red function, the green function here, f of x is a square root of x minus 3. Because it's negative 3, the k is negative 3, the parent function f of x is going to translate vertically 3 units down. You see it goes 3 units down, and all the points in the graph are going to translate vertically for 3 units down. If we look here in every point, the x coordinate in all 3 graphs of the function is the same. It didn't change anything. It didn't have any changes. But if you look here, for example, the y coordinate changed in the red function for 2 units, because this 2 indicates. Here was 1, and here is 3. Here is 2 y coordinate, but in this function, red function, is 4. And in the parent function, the y coordinate is 3, the red coordinate is 5. And same thing with the green function, because it goes 3 units down. This point changes for 3 units down, and this point here changes the y coordinate for 3 units down, changes here, and here changes for 3 units down, and same thing happened with this point changes 3 units down. But if we want to look a little bit how it looks, for example, with the tables, when we created the table, we have this scenario here. Let's say we have 3 functions. We have a parent function, f of x, is equal to square root of x, red function, and green function. Now, we already created this table in the previous video, and we showed how we can find those points, because the x-axis we plug in instead of the x, and we find the f of x in each point here. But now, if we have a red function f of x, that is a square root of x plus 2, and now the changes, as we saw a little bit early, is happening just in the y-axis. In the x-axis, all the points are the same, and we see here are the same points, and in the green function are the same. But because here is plus 2, and every point in the y-coordinate is changed for 2 units. For example, here is 0, and here is plus 2. 0 plus 2 is 2. And x is 1, f of x was happening here, here is 1, and 1 plus 2, this 2 here, is equal to 3. And in this point here, here is 2, plus the 2 units that this changes is 4. And we are going in the next point, 3, plus 2 units is equal to 5. And the other one here is 4, plus this 2 units vertically up is 6. In the green function, because it's minus 3, every point in the y-coordinate is going to change for 3 units down, and we are reflecting here in this table. 0 minus 3 is minus 3 because 0 here, 3 units down. And here is 1, I'm taking 1 minus 3 is equal to minus 2. And here is 2, I'm taking 2 minus 3 is minus 1. And here is 3 minus 3 is 0. And 4 minus 3 is 1. So the new coordinates, the points are 0 minus 3 for this point, for the other point 1 minus 2, 4 minus 1, 9, 0, and 16, 1. Same thing happened with the red. With the red function, the coordinates, the order pair of each coordinates in the graph is going to reflect in those points 0, 2, 1, 3, 4, 4, 9, 5, and 16, 6. Just let me, and if you wanted to see how they are reflected in the graph, we already saw before, but those are the points how they are reflected in the graph.